Okay, let's go ahead and start section 1 of chapter 5. This is on multiplying and dividing fractions, especially fractional expressions. Okay, so part 1, multiplying fractions. All right, so when you multiply fractions, you multiply. You don't have to do anything fancy at all. You just have to multiply left to right. You don't have to. Well, we'll get to that. Do not find a least common denominator. We do that when we add fractions or subtract them. We need to find a least common denominator, but you do not need to do any of that when you're multiplying. You can just leave all the fractions kind of the way they are. You can do a little simplifying perhaps before you start multiplying, but nothing fancy like an LCD. All right. So if available or if needed or if necessary or whatever, uh, simplify. And this is what I was just talking about. Simplify the fractions by I don't know if I gave a lot of room here. By cross-canceling values that are diagonal from each other. And we're going to cross-cancel the values that are diagonal from each other by reducing them, much like you reduce a fraction. You're going to use a common factor, though, when you simplify them. All right. So I think cross-canceling is a very, I think sometimes people find it confusing, but I think it's a good skill, just, looking forward into algebra and the other math that you might have to take in the future. It's just a good skill to know how to do. All right. So like right here, oops, you're just, you're just multiplying. You're just multiplying left to right. That's all you're doing. You're just doing 2 times 4, and we're doing 3 times 5. That's it. It's just left to right multiplication there. And what do we get? 2 times 4 is 8, and 3 times 5 is 15. All right, for the next example here, we have multiplication. We have parentheses around the second fraction that that very well could have been left off. Okay, don't get confused by all that. But now this is a good one to show cross-canceling. This is what I mean. Like these numbers that are diagonal. Now we're not cross-multiplying these numbers. We're cross-canceling them. So, for instance, we're going to reduce them or simplify them by a common factor, and they both have a common factor of 3. And so that is what we're going to use. We're going to divide both the -3 and the 9 by 3. So that turns into 1. Now, both of these are negative, so we can just cancel off those negatives as well. All right, and 9 divided by 3 is 3. All right, we could do the same thing with the 32 and the 8. Now, 32 and 8, and the thing about cross-canceling too is, let's say you didn't particularly use the greatest common factor. As long as it's a common factor, I think you're making the process easier on yourself. Let's say we didn't divide by 8. Let's say you use 2 or 4. Those are fine. I think the point of cross-canceling is just to make the numbers more, just a little easier to work out. Okay, so we can divide these by 8, right? You can divide by 8. So 8 divided by itself is 1. 32 divided by 8 is 4. So now it's all ready to multiply. It's a very messy process too. You can see there, got things crossed out. You got numbers everywhere. But yeah, you have, so we're left with 1 times 4 and 1 times 3. So that comes out to 4 over 3. So that's 4 over 3. Or if you change it to a mixed number, 1 and 1/3. Okay. All right, next one here. I think the important part that you want to notice on this one is that 14 is a whole number, but if you want to imagine or think of it as a fraction, you can just put it over 1. You can always do that. And, or you don't have to, but I think it makes it a little bit easier. Right here, 14 and 28 have a common factor. They could be divided by 2, they could be divided by 7, or they could be divided by 14. I'm going to use 14 because that is the greatest common factor, and that's always the better factor to use, or the best factor to use. All right, 14 divided by itself is 1. 28 divided by 14 is 2. All right. And if we just multiply left to right, we've got 1 times 2, which is 2. All right. And then we also have 1 times 2 on the bottom, which is 2. And anything over itself, right? Anything over itself is just 1, isn't it? That's all it is. It's just anything over, same number over itself in the numerator and denominator. That just equals a big fat 1. Okay. All right, we got some algebra kind of mixed in on this example here. All right, and if we look diagonal, if we look at the diagonal relationships between the numbers, I don't see anything right here. Those don't have any common factors. Okay, 2x and 7 don't have any common factors. So we could just multiply left to right here. All right, so 2x times 3x. Well, 2 times 3 is 6, and x times x is x squared. Okay, we're kind of using that product rule right there. 1 plus 1 is 2, right? That is what that is. And then 5 times 7 is 57. No, it's not. I was joking. All right, it's 35. It's 35. All right. Okay, this one, a little bit more algebra going on there. The second factor there does not have anything in the denominator, so we could just think a default number there. We can put a 1. The 1 here. Now this one, I think we could benefit from cross-canceling a little bit. Like for instance, the 12 and the 30 both have a common factor of 6. So we can divide by 6, divide by 6 there. 12 divided by 6 is 2, and 30 divided by 6 is 5. Okay, and now we can just multiply left to right. So 4 times 5 is 20. 4 times 5 is 20. And then the x's, right? We've got x to the 5th, and we've got x to the 7th. That makes x to the 12th. X to the 12th. And in the denominator, we have a 2 and we have a 1. So 2 times 1 makes 2. All right. And sometimes we get something, but we can do a little bit more to it. Right here, the 20 and the 2 can both be simplified. That's basically 20 divided by 2. 20 divided by 2 is 10. So you end up with 10 x to the 12th. And we're finished with that one. All right, and then this example right here for E, lots and lots of factors diagonal from each other. There's a lot of common factors that we can work out. All right, let's work with the 15. Now 15 and 3 can both be divided by 3. So 15 divided by 3 is 5. 3 divided by itself is 1. All right. Oh, and then for the x's, we have x cubed, and we have x to the first power here, if you want to imagine there's a number there. So you got x to the third power, x cubed. So just use quotient rule. Quotient rule says that we can subtract the powers. So 3 minus 1 is 2. All right, and then we can just eliminate that x right there. All right, like I said, these get a little bit messy. Just important you kind of keep everything straight. And then the other diagonal, if we look at the other diagonal, they both have 5 as a common factor. So we could divide by 5, divide that by 5, divide that by 5, and you get -2. -10 divided by 5 is -2, and 25 divided by 5 is a 5 right there. All right, so let's make sure we got everything straight here. All right, so we have 5, and we have x squared, right? That's what we got there, times 2, times -2. And then we have 5 times 1. All right, so 5x squared times -2, that makes -10 x squared. And then 5 times 1 makes 5. Okay. And right here, all right, this 10x, or not just 10x, but -10 divided by 5, that could be divided. All right, -10 divided by 5 is -2. So we don't need a denominator anymore. So we got -2x squared. Okay, that's it for that one. All right, so I think those are pretty good examples to do because that kind of gives you a good taste of how to multiply fractions in general. All right, now let's move on to part 2, which is on dividing fractions. All right, so what are some important things that we need to know for this? Now, one thing that's kind of important is reciprocals, okay? Two numbers are reciprocal. Oops, I'm not spelling that right. Reciprocal. They are reciprocals of each other if their products equal 1. That means when you multiply them, you get a product of 1. The answer is 1. To find the reciprocal of a fraction, switch the numerator and the denominator. So the numerator becomes the denominator becomes the numerator. You just flip it, all right? So the reciprocal of 4/9 is, and we've got some examples here, the reciprocal of 4/9 is 9/4, right? We just flipped it. And we can prove that by just multiplying 4/9 times 9/4, all right? If I don't do any cross canceling, which you don't really have to do, you get what? You get 36 over 36, and anything over itself equals 1, doesn't it? There it is. All right, next example right here. All right, now when you do the reciprocal of a negative, some people mistake that the negative goes away. Nope, the negative sticks around. Negative has to stick around. So keep the negative there. Just flip the fraction, and you're good. So I'm just gonna make that negative. But the negative really could be anywhere on a negative fraction. Really, it could be, like if you have a negative three-fifths, for instance, you could have -3 on top, -3 over 5. You can have 3 over -5, or you can have the negative right in line with that, division line or the fraction bar. So it doesn't really matter if it's a negative fraction. Doesn't matter. It can be any one of those three. It's fine. So we got 5 and 3. So we're just flipping those. All right. So I'm going to do that. We got -3 over 5, and we have -5 over 3. All right. And here's the thing, just a negative times a negative is a positive, right? And so we're off to a good start there because we want to get +1. And 3 times 5 is 15. 5 times 3 is 15. That still equals 1, doesn't it? Okay. So we get the same thing. All right. On this third example right here, we've got to find the reciprocal of 8. Now, it's good to know, like if it's a whole number, it's always good to know that a whole number can be expressed as a number over 1. All right. And that helps you because then you know what the reciprocal is then, right? You know how to do that. So the reciprocal of 8 over 1 is a unit fraction. 1 over 8. A unit fraction is a fraction where the numerator is a 1. Okay, so you got 1/8 right there. And we can just 8 over 1 times 1 over 8 equals 8 over 8. And 8 over 8 equals 1. All right. The next little footnote here is every number has a reciprocal except for, what do you guys think that is? Do you guys know what it is? Every number has a reciprocal except for, well, I mean, I think, I think I'm thinking 0, but I think 1 could also be included because 1 has the same, but I think it's 0 because 0 could be expressed as 0 over 1, right? But if you flip 0 over 1, you get 1 over 0, which is that's undefined. You can't really do that. So 0 would be it. All right. I would say 1 has a reciprocal. It has a reciprocal that is itself. Maybe that's why I was thinking it could be 1, but what it is. All right. I wrote these notes after all, so I should know. Dividing rational numbers. So to divide two fractions, all right, what you're going to do is you're going to flip, find the reciprocal, flip the first fraction. Oh, no, you're not. See, again, I wrote these notes and I don't know what I'm writing. To divide two fractions, what you're going to do is you're going to multiply the first fraction by the reciprocal. What I want to say, by the reciprocal of the You're going to multiply the first fraction by the reciprocal of the second fraction. I mean, I put that in there, so I don't know why. So it's a little redundant, but I'm going to write it in there anyway. I think that's what I meant to put in there by the second fraction. All right. Oh, I know what that was supposed to be. That was supposed to be the divisor. You know, the number that you're dividing by is called the divisor. Anyhow, that's what it is. All right, so maybe you learned it this way. You know, why? Especially when I was younger, learning how to divide fractions, our teacher said K CF. I want to write KFC like Kentucky Fried Chicken, but KCF, keep, right? Keep, change, flip. Okay? Keep, change, flip. All right. And that's kind of a general, that's basically the algorithm for dividing fractions, right? So you keep the first fraction as it is, 7/8, right? We change division into multiplication, all right? And then we flip the second fraction. All right, so we change it to, so we have 15/16, now that turns into 16/15. All right. Another good rule here to follow is that, you know, I had a little discussion about cross canceling, which is a really, really good thing to be able to do. But to keep it in mind that you don't want to cross cancel until you've done this, until you've changed it into multiplication. I had a student tell me like she remembered like I don't cross cancel until I see the cross, which I thought it was a really good way to remember. Like it's an X, but it's in technically I guess you can call it a cross in a way, you know, like an X. Then the lines are crossing each other. So yeah, that's that. So then you can now we can cross cancel, right? 16 and 8 can both be divided by 8, right? So you got 16 divided by 8 is 2, and 8 divided by itself is 1. All right, and then what are we left with? Well, 7 times 2 is 14. 1 times 15 is 15. So it's 14/15. All right, next one here. All right, I think, you know, whenever you have a whole number or an integer, just put it over 1. Just kind of make that kind of your automatic thing to do. And we're going to keep the first fraction the way it is, -2/3. We're going to change division into multiplication, and we're going to flip 6/1 to unit fraction 1/6. All right, on this one, we can cross cancel the 2 and the 6. We can divide by 2. We can divide those by 2, right? So -2 divided by 2 is -1. All right, 6 divided by 2 is 3. So now we've got it all. So -1 times 1 is -1. 3 times 3, we have a 3 here, and we're multiplying by the 3 that we ended up when we cross-canceled, is 9. So there you go. You got -1/9. Now remember, you can have it in the top, you can have it in the bottom, the negative I'm saying, I'm referring to the negative, or you can have it right in the middle, you know, like that. 1/9, -1/9, like that. All right. Oh, and I kind of spoiled you on this one. I put on here, breaking news, only cross cancel once the reciprocal has been found. All right. Remember to cross cancel when you see this is what I was just talking about. It'd help if I looked ahead. Cross cancel when you see the cross. All right. And then just give these a go. Try these out on your own. Pause the video and see how you do. And then unpause it and just check with me. And I'll just go ahead and solve these. Okay, so I got for the first one there, I got 8/3, and that's okay to leave it improper. It's fine to leave it that way. I just think it's always a good idea to simplify if you can. If it's reduced to lowest terms, 8/3 cannot be simplified. However, it can be turned into a mixed number. So I wrote 2 2/3 as well. Both of those are perfectly fine answers. And then on the second one, I got -2/9. All right.